in search of soil.
When you look at traditional agricultural practices, you have chemical fertilizer, you have chemical sprays for herbicides or fungicides, you have tillage. Is there one of those that you think is worse than the others in terms of depleting soils of organic matter and reducing biodiversity?
Of course, all of these practices can reduce organic matter and reduce biodiversity, but especially for for fauna, for soil fauna and microorganisms, tillage is and plowing are very important, relevant. So we observed significant increases of biodiversity in plants, about plant biodiversity, soil biodiversity, in the no-tilled soil, or in soils with minimum tillage. Why this? Because most of the fertility of a soil and of the biodiversities is in the first 30 centimeters of soil. And the traditional practices adopted by farmers in our area plow soil, included soil plowing up to 30 centimeters and more. So they can destroy completely the macrofauna. And in this way, we select bacterial and fungal groups that are deleterious for the agroecosystem. And we destroy fungal hyphae filaments. And these filaments are extremely important because they are a kind of concrete between soil and the other elements. So a sustainable soil rich of fungal hyphae can resist to erosion, can resist to runoff, to soil losses. And so there are a wide range of benefits. All these benefits impact on soil biodiversity, soil organisms, especially the macrofauna, like earthworms, ants, beetles, for example. And these fauna contribute to the soil fertility, to the biological soil fertility. And they also affect the physical status of a soil because increase macroporosity. And if we increase macroporosity, we also increase water retention, we increase soil gases and oxygen, so the soils are well aerated, rich of oxygen. And we avoid the proliferation of deleterious bacteria like denitrifying bacteria that are abundant in asphyctic soils.
When you look at no-till versus minimum till, no-till I think you would say would be better than minimum till. How would you define minimum till?
I can give example from our system, the olive orchard we are talking about. No-till is completely, it's a soil without any tillage. But sometimes minimum till is necessary. For example, when the pruning residues or the crop residues from cover crops are cut, they must be incorporated into the soil. So sometimes, and we have to cut this because, for example, cover crops compete with plants for water because water is a limiting factor in our environments. So they must be cut. When they are cut, they must be incorporated into the soil. So sometimes a light harrowing is incorporation into the soil. A tillage up to 10 centimeters is needed, or 10 centimeters to incorporate this organic matter into the soil and favoring the process of humification.
If you look at the soil profile,
Yeah.
so here you have surface and then you have below the soil. If you're only tilling 5 to 10, you're up here. And then, traditional tillage, you were saying, could go down to 30. What band of the soil profile do you think plays the greatest role when it comes to agronomy of growing crops? In other words, is there one band of this soil that you really do not want to disturb, where a lot of the organisms are, where a lot of the action's taking place? So is that why it's only 5 to 10 centimeters deep? Because that band isn't as important as, say, 10 to 30?
From my experience and considering our experimental fields, our fields are in arid environments. So the first centimeters of soils usually are not so wet like the band from 10 to 30 centimeters. And most of the soil moisture is in that band between 10 and 25 to 30 centimeters. But also, so most of the biodiversity, if the soil is not disturbed, of course, and of macrofauna, biodiversity is in that band. So mostly depends also on irrigation, of the irrigation type. If the soil if an orchard is drip irrigated with microjets, or just applying water on the whole surface. And of course, another part very rich of biodiversity is the rhizosphere. So it is the independently from the depth of soil, is the area close to the root surface. So I think that if we apply minimum tillage, there is not a big damage, even because many soil organisms live not in the litter, but in the layer between 10, 15, 30, 40 maximum centimeters. Many earthworms, for example.
If you're in an arid environment and you have that band of soil at the top, that it kind of acts like a mulch, right? It dries out and it prevents transpiration directly from the wet to the atmosphere. If you had that cover crop growing and you cut the cover crop and you just let it lay on soil surface instead of integrating it in, and you move that wet band up higher directly to soil surface, is there a benefit to that? Is there a benefit to having a complete organic matter cover litter over the whole surface versus a more bare surface with that dry band?
So you mean the difference between incorporating the organic matter applied into the soil, the first layer of soil, or let it on the surface?
Yes.
Yeah, there are benefits, and it depends. Of course, if we leave the organic matter from pruning residues from cover crops on the surface, we have benefits because we reduce transpiration, we reduce erosion, and we don't disturb at all the soil. So microorganisms are very well preserved. But the mineralization of this organic matter is lower. So we need time. And so this is a good option if we combine the residues kept onto the soil, above the soil, together with mineral fertilization. But if you want to produce humus and let that nutrients are released from organic matter, we need to incorporate it into the soil, at least in the first centimeters, because just in the soil we have much more than in the litter. We have the highest soil activity, biological activity. And another important factor is the surface to mass ratio. So it is very important, at least in our climates, to increase the surface of the organic matter. So we have to shred the leaves and pruning residues and everything. And this allows microorganisms to decompose fastly, and the organic matter. And it also depends, the choice depends also on the water content and on the irrigation type. If the water content is high, we can leave the organic matter above the soil, like a kind of cover onto the soil. If the soil is dry, it is better to incorporate the organic matter, the residues, in the first centimeters, where the activity of microorganisms is higher due to water content, to the humidity. So the choice depends mostly on the climate and on the irrigation type.
If you were in a lab setting and you had two pots, and one had, let's say they're 1 meter deep pots, and you had one where it had a 10 centimeter band of dry soil at the top, and you put plant A in that pot. The next pot, same depth, same plant, goes in, but soil was wet, like you ensured that soil was wet directly to soil surface. Do you think you'd see a difference in plant health in the soil that was moist, the 100% of the soil profile, versus one that was only moist some level below the surface?
Yeah, also in this case, it depends on the crop. I have experience with orchards, so with 3 crops. And what did I learn from these systems? That, of course, we have, compared to herbaceous crops, we have deeper root systems. But also in this case, the situation changes according to the crop. For example, if we compare 2 extremes, so if we compare olive tree is a typical crop from our environments, our climates, our soils, and kiwi fruit, for example, that is also cultivated in our systems, we have 2 completely different behavior. The root systems of olive trees are very deep, up to 2, 3, 4 meters. And so the absorption of water is mainly concentrated in below 50 centimeters and more. So in that case, irrigation is quite important. For example, drip irrigation. So concentrating the irrigation just in the soil where explored by roots, and let this water go down. So the water must have the time to arrive to the deepest layers of the soil. But this, and for olive, for example, we have very high water use efficiency, and they can resist to very low water potential, so very low amount of water into the soil. If we compare this crop with kiwi fruit, for example, the roots morphology and system is totally different. Kiwi fruit has a shell of root system. So the roots develop in the first layer of the soil. And they explore the first layer up to maximum 30, 35 centimeters, not more. So if we cultivate, for example, olive in a soil with a dry layer, a dry topsoil, it doesn't matter. It is not so important.
Right.
If we cultivate kiwi fruit, it is very, very important. So it mostly depends on, also in this case, on the crop, on the tree crop, and on the irrigation system, that it is applied according to the crop that is cultivated.
Yeah, so most people listening to this are going to be growing herbaceous crops, vegetables, and I would think they'd be closer aligned to kiwi than olives.
So for vegetables, also in this case, I did some researches about them, and the root morphology and root architecture is very, very important also in this case. So if we cultivate, for example, cabbage or rapeseed that belong to Brassicaceae family, they have a taproot, so a very long root deep into the soil. So in that case, they are less affected by dry topsoil. If we cultivate, or cereals is the same. If we cultivate other crops, like legumes, for example, they have a more diffuse root system, so not a taproot system. And so they are more influenced by the moisture in the topsoil. Yeah.
I know you did a study looking at different forms of irrigation, and you've alluded to this a little bit. The most common forms of irrigation here in the States would be drip and then just overhead sprinkler. So when I think about the two, and I guess microjets are going to be similar to an overhead in terms of coverage. When I think of drip, you get a concentration on one point of the soil, and then it kind of bubbles out over time. When you get a microjet or sprinkler, it's like rain. You're applying it evenly over the surface. How should growers think about irrigation systems and the differences between a microjet or overhead versus drip, and how that could affect plant growth?
Yeah. Firstly, the most important thing is the efficiency of these systems. Drip irrigation is very efficient. So the amount of water is required is very, very low compared to the microjet. And for drip irrigation, we use them in several agroecosystems, for several crops, especially for tree crops, for peach, for example, for nectarines, for olive. And it is very, very efficient. And we cover, on average, the 20% of the soil surface. This system has many advantages from an environmental point of view, because the wet soil is less. And in the wet soil, we have the highest losses of carbon, as carbon dioxide, because soil respiration is very, very high. So we have losses of carbon and losses of organic carbon. but concentrated just where the drip drip system is located. If we apply microjet, of course, we must use much more water. The efficiency is 65-75%, and we can cover almost the whole soil. And also in this case, it depends on the crop. It depends on the root system. So the choice of an irrigation system is based mainly on the water availability, firstly, but especially on the architecture and morphology of the roots of the crop. So if a root is concentrated, is below the plant, is a taproot, is along the soil profile, it is deep. A drip irrigation can be fine. If the roots are shallow or they are concentrated in the first layers of the soil, in that case, microjet is preferred. And also in this case, from my experience, we have crops that are that need a microjet. For example, kiwi fruit is like that. And other ones that are better with drip irrigation. With drip irrigation, we have many benefits, environmental benefits and economical benefits.
So in thinking about that, I mean, that makes sense. If the crops that get most of their benefit in the upper soil profile, then you want that to be as wet as possible because that's where their roots are. That's where you want biological activity. If the plants are going deeper with their roots, then drip's okay because the water's just going down, and it's not covering as much of that upper band. That's the basic gist of it?
Yeah. That's the basic reason of the choice. And of course, mostly depends on the water availability in the place where you cultivate. And in fact, drip irrigation was discovered and applied in Israel, for example. They are expert in this, but now it is spread in all the Mediterranean basin for tree crops, for example. So it depends on the crop and on the crop density and the water availability,
right?
The choice. So it is not a matter of arid or wet climate, but it depends on the density and on the root morphology.
Does tillage play a role in soil drying out? If you had an area that had a nice moisture profile in the soil and I till it, is that soil going to want to dry out faster now?
Mostly depends on the soil composition, if it is a sandy soil or a clay soil. And usually if we till, we have, in most of the cases, we have loss of water from the topsoil and a higher mineralization. So we have losses of water and of carbon at the same time. And another danger is that if we plow or we till, we can have soil compaction. So we have a losses of water and carbon from the top layer, and at the same time we have compaction, or in the worst case, sealing of the soil, the deeper layers. And I was reading yesterday that most of the most fertile soils cultivated lost from 20 to 60% of organic carbon in 50 years. The prairie soils, the most fertile soils. And in Germany, where I am actually, we have losses of 60 hectares per day of soil, 60 hectares every day, and of soil seeding, so a soil that is completely lost forever. And Italy, where I come from, where I work, is the country, the European country with the highest consume of soil. We lost in the tilled soils, we lost 100 times more soil by erosion compared to the sustainable soils. So the erosion is 100 times faster. And this is very similar to the results that we had in our systems.
When you read this, you're doing research, and this is over, like you said, a medium, long-term, 20-year study. Why isn't sustainable agriculture viewed as a better option for people doing the farming? Why does conventional still hold so much clout when the data seems to show that one is clearly better, not just for now, but for the future?
This is a very interesting question and very complex. Because I think at least me, I work in academic, and so among the researchers, these things are very well known. If we read the FAO reports, the IPCC reports, and other reports, all of them say that soil is important, not only for a productive point of view, but from economical and environmental point of view. And the environment today is extremely important. We are looking at the effects of climate change, and we don't think that soil contains the amount of carbon of the atmosphere and of the biosphere at the same time. So the carbon stocks in the soil are very important. And so carbon can be a sink for carbon. Soil can be a sink for carbon. But the problem, at least in the country where I live and I work, is the dissemination of this message to farmers. Now the things are changing very fastly. In the last years, the integrated agriculture, the regenerative agriculture, the organic agriculture increased a lot. And the organic production in Italy is today very high compared to 20 years ago or 30 years ago. So the message are arriving, but there is a kind of, we need time. Time is needed to transmit this knowledge to the young generation, to the young farmers. Many of the young farmers that are starting to cultivate, especially after the economic crisis, they decide to be farmers, have a degree, they have studied, so they know these things. While the traditional farmers of course are more ignorant, so they cannot perceive the message behind these new practices. Mm-hmm. So I think that we must focus, especially academia, universities, research centers, on the communication and dissemination, starting from the children. So I think that the reason why the sustainable techniques, eco-friendly techniques, there are several names, but the substance is always the same. The reason why they are not applied is that the concept, we should transmit the message that agriculture is important. It's a multifunctional activity. it's not important only production, but it is also important sustainability. So your soils must be fertile for a long time, for many generations. And the benefits must not be immediate, but they must last during time. And most difficult is understanding for the farmers is understanding the importance of their activity for the environment, the importance of the soil management on the environment. But today the things are going much better than 20 years ago. There is a lot of research and a lot of divulgation, dissemination. I look this positive from a positive point of view.
And did I hear you right that the soil holds as much carbon as the atmosphere and biosphere combined?
Yeah, soils have the same carbon of the atmosphere and the biosphere combined. So it's and of course the most important sink for carbon is water, oceans, and the oceans every day mitigate our effects, deleterious effects on the environment. They absorb a lot of carbon as carbonates. But soil, after oceans, soils are the second sink of carbon in the world.
In trying to build these complex soils that can sink carbon and all for getting kids involved early, I mean, when you start to look at some of the macrofauna, I mean, that's where I think kids can see that. It's not something you need a microscope for. They get it. Can you talk about the importance of soil macrofauna and maybe even start out saying, define what is macrofauna? Because I think people take macrofauna in the soil for granted and microfauna get all the credit and all kind of the popularity.
Yeah, so the scientific definition of microfauna is animals below 100 microns. 1 micron is 1 million of a meter. And for mesofauna, we define organisms between 100 and 100 microns and 2 millimeters. For macrofauna, we can imagine earthworms, for example, or insects. We define animals, soil animals, from 2 millimeters to 20 millimeters. And then we have megafauna, the animals that are visible, the more evident animals that are above 20 millimeters. And in addition, we have another definition, very common to find, is microflora. It is scientifically is quite wrong because it's not a flora, they are not plants, but they are bacteria and fungi. And so we have these 4 components that work all together in the soil. So we can see the soil, we should imagine the soil not from only a productive point of view, but under an holistic vision. So the holistic vision, there are several researchers, recent researchers, that explore the soil not only from a mineral point of view, but also from a biological point of view. In a soil, there are minerals, there are organic matter, there is organic matter, there are animals, there are bacteria, there are fungi, there are microorganisms, and of course there are also pores filled with water and air. So soil is a living system. It is not something dead. It is not something where organic matter only decomposes, but it is something alive. And if we imagine that 25% of soil of biodiversity is in the soil, 25, 1/4 of biodiversity is in the soil, and most of this biodiversity is not known at all. If we imagine that ants constitute the 10% of the biomass of all animals altogether, we can have an idea of the importance of soil from a biological point of view. Of course, from a scientific point of view, soils can be considered as soils even if there is no life in them. We talk about soils from Mars, for example, planets, soils from deserts, where there is no life or there is little life. But in most of the cases, soils are alive. There is a cooperation between microorganisms, plant, roots, animals, and so fauna, and that work all together in soil composition. And I had a lesson from a very important for me, in my opinion, Italian pedologist, maybe not very well known. He is Giovanni Hausmann. He considered the soil as a placenta. I'm reading now. And what he said, the man who physically and culturally is far from natural environment, from the soil, from agriculture and tradition, can be considered as eradicated, alienated, confused, capable of only damaging himself to others and to the environment. So soil must be seen as a living ecosystem, and all the production 90% of life depends on soil.
The macrofauna in the soil, so that would be worms, ants, beetles. What role are they playing in all of this? Let's start with worms.
The most important, they have several roles, and most of these roles are beneficial from soil. And earthworms, for example, termites, ants, some beetles, can be defined as ecosystem engineers. Why this definition? Because they dig into the soil, they build nests, burrows, and they mix organic matter. So they are like engineers. They change physically and chemically the soil. And so they increase macroporosity. So the soil with macrofauna are usually richer of air, of oxygen. They shred organic matter, leaves, and so residues, and they increase the surface of this organic material. Increasing the surface of this material, microorganisms, so bacteria and fungi, can decompose better this material. And so if they decompose better, more nutrients are released, more nitrogen, more phosphorus, potassium. And so plants can absorb more nutrients. So soil fertility increases. So it's a kind of trophic net where you have the producers that are roots, they're plants, photosynthetic organisms, and then you have the shredders. Macrofauna usually do this, so they cut organic material in smaller pieces. And then you have the decomposers that are mostly microorganisms. So macrofauna has a very important role because macrofauna live, in the soil, usually in the topsoil, but most of organisms are concentrated in the litter, but some of them can live the deeper soil. So it is the main advantage is the physical changes that macrofauna causes in the soil. And these physical changes in turn can affect chemical fertility and biological fertility of microorganisms. So everything is interconnected, intertwined.
If you think about ants, I don't think they get any credit, at least with even gardeners, when it comes to building soil. I think worms get all the credit. What role do ants play? And in hearing that quote that ants are, 10% of biomass? There's a lot of ants. What are they doing in the soil?
Ants are concentrated in the hot environments. So in the arid environments, much more than in the coldest part environments. But ants are ecosystem engineers. They protect at the same, so they change the physical structure of the soil. They are very strong predators of pathogens, of other organisms that eat plants. So they are competitor of herbivores, for example. So they can protect plants from other organisms, and they can protect roots from damaging insects. They can change with their nests, they can change the physical structure of the soil. So they can increase water infiltration and water holding capacity. And so in aerated soil, you must, for example, irrigate less. So you have benefits because your soils are richer of water. And so all these faunal organisms are not dangerous for plants.
If you look at ants versus earthworms, if they were in the same environment, do you have a sense of which one does more in terms of aeration, creating microporosity? Is it worms or is it ants?
Both are quite similar from a certain point of view for the size, more or less, and they are part of the macrofauna. They can be defined macrofauna, but their functions are totally different. Earthworms are more abundant in the wet soils, so they need more water. And ants are more abundant in the dry soils. Both are ecosystem engineers, so they change the structure of the soil. But there is a difference because usually ants eat sugars, so they have different. They eat differently, while earthworms eat soil. So eating soil, they mix this soil with enzymes of their gut, their stomach, and they excrete the soil, the same soil, enriched of enzymes, enriched of other organic matter. So the casts of these earthworms constitute a very fertile soil. So the earthworms are plow soils. And so they mix the organic matter and they cause the bioturbation. The bioturbation is the change of the soil, of physical structure of the soil. They mix, for example, they transport the fertile soil and the topsoil to the deeper layers of soil. So they increase also the fertility of the deeper soil, and they increase aeration. They increase organic biological activity. They enrich soil with enzymes. Ants are different. Of course, they can physically can change the physical structure of the soil, but are not so efficient like earthworms. And this is also why Darwin spent the last years of his life studying macrofauna, studying earthworms. He wrote a book on this.
If somebody wanted to increase the number of earthworms in their soil, is it as simple as add organic matter and moisture?
Simple, yeah. Earthworms are not so exigent, and they don't require much, but they for sure they need water and organic matter. They live in the decaying organic matter, decomposed organic matter, and at the same time you need for sure water. So these two things are important for their growth. And of course, you can enrich soil. You can also buy earthworms and increase the earthworms activity and earthworms abundance and number in your soils. It's a practice that it is normally used, increasing by adding earthworms to the soil. But you must prepare the conditions for their growth. But in this case, it also depends on the species of earthworms. Some species of earthworms live in the litter. Other ones in the topsoil. Other ones go deeper. So if we want to increase earthworms, I think the best way to do is not adding by yourself, because it is very difficult, hard, because especially if you have big lands, big soil surface, you will need so many earthworms. But it is avoid tillage, increase organic matter, and increase water, if possible. These are the three conditions. Because earthworms perturb, change physical structure of the soil. They mix the soil, but of course they can be reduced if the soil is tilled.
When you look at increasing porosity in the soil through macrofauna, they're digging all these tunnels, allowing air and water to get into the soil. That's one of the reasons we try and do tillage, or we do tillage, is to try and recreate that. Like we take a dense soil and we want to fluff it up. But we know when we do tillage, you do that and it deflates. It collapses. Yeah. Why don't the tunnels and all this activity from macrofauna, why is there no collapse from that?
Yeah, that's a very, very good question. And I think that tillage is it's a very strong practice. So it is it disturbs the soil completely, and it destroys the macro aggregates of the soil and the physical structure of the soil. So the main reason why we till is not improving the soil fertility or soil aeration, but eliminating weeds Yeah. So if we want to eradicate plants, we till. If we want to have the soil bare, completely bare, we till. So it is a very easy practice to apply. So we usually till the soil because it is simple. On the other side, the activity of macrofauna is completely different. It is not so intense like tillage. It is distributed in different layers of the soil. So there is a kind of equilibrium. So if we think that the evolution of these organisms, we can imagine why they are called engineers. They are called engineers because they know, not in a conscious way, of course, they know the limits of the soil. So they know how to build. They know the density of the nests, the density of the tunnels. They are in equilibrium with the soil, and they act in a long term. So it's not like tillage, it's like plowing. That is an intense and strong practice that disturb and destroy completely firstly the physical part of structure of the soil, but after the physical changes we have also the chemical changes, and after the chemical changes we have a decrease of the biological fertility, and we expose the soils to oxidation, to the oxygen. So we have a very high mineralization, and it has sense only if combined with mineral fertilization, while the fertilization carried out by macrofauna is completely sustainable. It doesn't require external inputs. I think that if we till a soil, apparently we increase aeration in the first layers, but at the same time, we cause compaction in the layers below. In many Italian soils, after 20, 30 years of intensive cultivation, we have very severe problems with soil quality. Many of our soils are compacted after 20 years of tillage, 20 years of mineral fertilization, 20 years of decrease of organic matter, 20 years of 20 years of decreasing biodiversity. So apparently, if we want to act faster, we plow, we till a soil, and we increase aeration, of course. But at the same time, we don't know other secondary effects of tillage. In the subsoils, many often I observed a soil compaction that starts from 40 centimeters of soil. So many farmers try to avoid the detrimental effects of the decreasing soil fertility, by increasing soil mineral fertilization, water supply. So they irrigate more, they put more nutrients, more fertilizers, trying to save plants, to save crops, because they only concentrate their attention on the first layer of the soil. They often don't know that soils after below 30, 40 centimeters, 50 centimeters are completely compacted. So if we till a soil for a long time, of course, we have an increase of soil aeration, but it is often just apparent. It is not like that. It is the situation is totally different in the deeper layers of the soil, where aeration is very, very low. In many soils, also recently, in the trials that we are conducting, I observed compacted soils without macropause. There are increases of carbon dioxide, and they are normal because there is a soil breath. But the differences with sustainable soil are very, very high. So the physical damage of the soil decreases their fertility.
So if you didn't turn the soil and you had compaction, well, let's say you had compaction to start and you want to speed it up, to speed up the reversal of the compaction.
Yeah.
If you ran a subsoil plow through there that didn't invert, it just helped break up that compaction from below. Do you think that's a path worth looking at, or is that a tool in the toolkit, I guess is a better way to say it, to move towards something more regenerative, or do you think that it's just not needed at all?
Yes, maybe you mean soil reapers. So kind of
like
practice,
a rip. Yes.
like a reaper. Yeah.
Yeah.
In many cases, this is very effective. Soil reapers are very effective because they don't disturb the soil layers. They don't mix the soil. They don't expose the soil to oxidation, but they increase aeration from the cracks they form. And this is a good method. So especially for tree crops, when we want to regenerate the root system. If a soil is compacted, usually we have problems with roots because roots need oxygen for respiration. And if a soil is compacted, the oxygen content is quite low, so the roots start to decompose. What can we do in this case? We can use reapers to cut the dead roots and let them regenerate again, increasing soil aeration. So another good option is, for example, in tree crops, is the digging the soil in the interrow area, for example, and filling them with, so just not along the tree row, but in the interrow areas, and fill them with organic matter. This is so sacrifice some parts of the field, and so working in those parts and filling them with organic matter, so increasing aeration because soil gases can diffuse both vertically and horizontally into the soil.
Have you ever seen this tool, a broad fork?
Just let me. I have never seen it, but no, I have never seen it.
So the theory would be you push this down into the ground. This is on a small scale, like the farmer is standing on it, and then he pulls back on those poles, and those forks slice or kind of cut up through the soil, and you work your way down the field. Push it in, slice. So it's a way of, on a small scale, aerating the soil while not mixing the layers up. And I was just curious if you had any thoughts on that.
I've never seen it, but I can understand the importance, the function. Of course, it can increase aeration, but can it be applied in a productive field? It is, I think, so much labor
It'd be very small scale. Yeah, you'd have to have a
small scale in the
Yeah.
permaculture, for example. At small scales.
I guess coming to this then, what do you think if you had restored soils using regenerative practices? Do you think you'd ever need to do anything to the subsoil? And you just say, hey, let the roots, let the macrofauna, they'll do it. Once you get your soil to a certain point, is there like a point of you never have to till, you never have to do subsoiling, you never have to do a ripper, because the soil's nature is taking care of that? Or do you think there always is a need, to some extent, to some degree, to go back and maybe have to do those types of activities?
This is the principle of permaculture. So let the environment as it is. So in the productive crops, I think it's very difficult. So there is always something to do. It's very hard to let the things as they are. So it can be a disease, it can be a decrease of organic matter into the soil. So you have to increase organic matter, adding compost and manure, or you have to contrast a disease, a pathogen. So this equilibrium is not possible in agriculture, in the productive agriculture. Why? Because like I said before, agroecosystems are ecosystems. So of course they reach an equilibrium, but this equilibrium doesn't give benefit only to the crop, but to the whole community of organisms. And so in the productive agriculture, of course, there are less intensive organic practices. There are sometimes you can apply natural products and not mineral fertilizers, for example, or other produced substances. But you have, from time to time, you have to do something. Different concept is in the permaculture, where there is an ecological view where crops are not at the center of the ecosystem, but they compete naturally with other plants or animals. But you can do this at a small scale. But if we imagine that 1/3 of the soils are lost, we lost 1/3 of the fertile soils. So soils are becoming more important than water. They are a natural capital. And we are almost 8 billion inhabitants. Food is not enough for everyone. So regenerative agriculture and sustainable agriculture is very important, but of course it requires labor.
Right. So I'm maybe thinking of that in a practical sense for farmers. It's do as little as you need to do in terms of interfering, but at the end of the day, you are producing a crop. You need that crop to grow well. So if you have to step in with certain practices, then do it. But, there's always choices. One is more of a gentle approach. One is more of a harsh approach.
Yeah, the gentle approach also requires knowledge. So you can act gently on the crops if you know how the agroecosystem works, how they function. So knowledge is very important. Sustainable agriculture it is possible to apply sustainable agriculture. There is a lot of scientific knowledge on this. The problem is disseminating, transferring this information to the farmers.
Yeah.
Yeah.
Well, one area I'm thinking of now is organic matter, and obviously it's important on the small scale. A lot of farmers are adding organic matter to the soil with compost. If you had two scenarios, one would be, let's say I laid down 3 centimeters of compost directly on the soil surface. I didn't integrate it into the soil. I just layer it right on top.
Yeah.
The next would be I put down that same 3 centimeters, but I mix it into, say, the top 10 centimeters. Would the difference between those methods be, in case one, it's going to mineralize slower because I have to wait for the macrofauna to get it and bring it down, and I maybe prevent some evaporation because I now have this organic cap.
Mm-hmm.
And then in scenario 2, where I've mixed it in, I'm putting more food into that upper horizon of the soil, so it's mineralizing faster. Is that really the only difference between the two? Is it a mulching effect and a mineralization rate effect, or is there something else I'm missing from layering versus mixing?
Of course, if you don't mix the organic matter, you preserve soils entirely. So you don't disturb any macrofauna, you don't disturb animals, you don't disturb hyphae. So it is not only mineralization, but if you don't incorporate the organic matter into the soil, you preserve biodiversity of the soil. So you preserve the ecological niches, the ecological habitats of many microorganisms and fauna and soil fauna. So it has beneficial effects on soil biodiversity. This in turn gives also benefits to the agricultural production. If you preserve the fungal network, plants and crops, of course, can absorb much better nutrients, for example, phosphorus, because the fungal filaments, the hyphae of the fungus, help plants to absorb nutrients. At the same time, many microorganisms produce exudates. Also roots produce exudates, so substances that are secreted from their bodies. And these substances can act as a kind of glue. So they preserve soil aggregates and they keep them safe from erosion. So different is the situation of incorporating the residues into the soil is totally different because you destroy much of this biodiversity.
From all your work studying systems, how would you define what sustainable agriculture is today?
Sustainable agriculture is something that can last over time. So it requires, of course, life, biodiversity is extremely important for sustainability. If we don't want to intervene continuously on soils, we must accept that most of the work must be done by soil organisms. We don't have to reduce soil biodiversity. And sustainable agriculture is something that is regenerative. It is not necessarily organic. It is something that increases carbon into the soil, that increases biodiversity, it can be defined as restorative conservation agriculture, something that preserves soil, but soil viewed as a living ecosystem where there is a kind of equilibrium. So we must preserve this equilibrium.
What would you want farmers to know if you look at your research and thinking about the future?
I think that farmers should know that they have a capital in their hands. They have precious things. They must preserve resources, preserve water, but not only water, considering the interactions between plants and soil, considering the importance of soil biodiversity, considering the soils as alive. So they should be convinced on this, and for convincing them, it's important to know that environmental benefits can give economical benefits. So in the short term, conventional intensive agriculture can seem better, but in the long term, in a durable term, if we consider more year, a longer period, sustainable agriculture is more convenient from different point of view, because soils not only give production, they are not only useful for production, but they are useful for a wide range of ecosystem services. They purify water, they purify atmosphere, they act as a sink of carbon, they can contrast climate change, they can preserve biodiversity in their layer, they can be extremely important, not only for production. So the responsibility of the new farmers, so the young farmers, is huge today. They can contribute to the future of the earth, of the planet.
Hi, everybody. Thanks for watching. Subscribe here to get the latest from the show. Also, be sure to check out some of the great clips and watch the full interviews right here on In Search of Soil.